In this video, we will see Mohr's circle, which is a graphical method to find the principal stresses. Here, if you see, same stress element as in the previous video. So sigma x is acting on this vertical plane, sigma y on horizontal, and tau xy is on all the planes. One is externally given, and two are complementary shear stress. Theta is a random plane oriented with this vertical plane where sigma x is acting. So we have to find stresses on this plane, and also we have to calculate the principal stresses. So now here is a graphical representation of the Mohr circle. As you see here, we'll go step by step. So first we have to draw this horizontal and vertical axis and give a coordinate 0 0. So this is our reference point. The horizontal axis is a sigma, where all the normal stresses will be pointed, and vertical is a tau s with a shear stress. So we have seen two equation, sigma normal and tau s in the previous video. So both these values we are plotting in x and y direction. So in x sigma and y tau s. Now here first we have to find sigma x and sigma y. So as per the scale, whatever the value of sigma x and sigma y is given, we have to plot it. So we have to find sigma x. So on x axis, sigma x will be somewhere here and sigma y will be somewhere here. So we have plotted sigma x sigma y, and we have to move in vertical direction for tau x, tau xy. So tau xy downward we consider as positive. So on downward direction here, whatever the tau x will be, similar distance will be on the other side. So we will get 2 points. First point will be this and second point. So sigma x tau xy we have to plot, and sigma y tau xy we have to plot. Now we have to connect it, and this line we have to find the center point, or we can find center point from this 0 0 by this sigma 1 plus sigma 2 divided by 2. But here we don't know sigma 1 and sigma 2. So first we have to draw this line, and wherever it is intersecting on this horizontal line, that will be the center, and that will be equidistant from both these, because this is the radius of the circle, and throughout the length will be diameter. So now this will connect at the midpoint of this line with this horizontal line, and we have to draw a circle with this radius. Whatever the length we get, we have to draw a one circle by keeping this as diameter. Now after we get the circle, wherever wherever the circle cuts the x-axis, means sigma axis, here and here. So this point will be our sigma 1, which is a principal stress, and sigma 2 is a minor principal stress. So sigma 1 is major principal stress, sigma 2 is a minor. So from 0 0 to this much distance, if we measure it, that will be value of sigma 1. And from 0 0 to this value, means in minus, in compressive direction, this is a minus. So here sigma 2 will be in minus direction. So that will be minor principal stress. Now this vertical line, if we draw from this point, then we'll get tau max, which is a shear maximum stress, and that will be the radius of the circle, radius of the Mohr circle. We know the equation of tau max. This is the equation, and we can also find from this principal stress, if we take the average, means the radius only. If we take sigma 1 and sigma 2 average, then we'll get radius only. So that will be similar to tau max. To find the center point, we have to add sigma 1 and sigma 2, and then divide by 2, we'll get the center point. Now each point denote a plane. So each point on a Mohr circle, any point, random point, like sigma x and tau xy is this particular plane here, sigma y and tau xy is this particular plane. But in between there is this theta random angle. In between there are infinite planes. So all the planes will be denoted by this Mohr circle, and different value of stresses will be there. The normal stress will be, if we plot any point, let's say this point, if we plot on the x-axis, we get normal stress, and on y-axis we get a shear stress. So all the planes denote all the points denotes one particular plane on our stress element. um, it is at particular angle from our reference line. Now if we measure angle from our sigma x tau xy to the horizontal line of principal plane sigma 1, because this particular point is our principal plane, so we will get principal plane angle. Here in our equation there was 2 theta, so that's why in Mohr circle we get 2 theta, and in our stress element we just have theta angle. So here if it is 2 theta, then if we take theta p1, then we will get the principal angle, but on Mohr circle we will get 2 theta p1 between 2 points. So if we draw a 45-degree line from our reference plane, then here this sigma x plane and this 45-degree line plane will be having 90-degree, because here 45 in stress element we have 90-degree in Mohr circle, and we see sigma x and sigma y oriented at 90-degree. This particular plane and horizontal plane are at 90-degree, but you see here sigma x and sigma y are at 180-degree from each other. So on Mohr circle we have to take 2 theta, here only theta, on stress element theta. Now if we plot from sigma x to the sigma 2 line, means minor principal stress, we'll get 2 theta p2, another principal angle, and between these two angles there is a 180-degree on Mohr circle and 90-degree on stress element. So this is how we have to plot a Mohr circle. We get quick values from this, but we have to draw it as per the scale. Now special cases of this Mohr circle are: first case is where we have sigma x and sigma y value both similar, means in both direction either compressive or tensile, but the magnitude will be similar and the direction will be similar. So if both are 50-50, plus 50 plus 50 in tension, then they are equal. Either minus 50 minus 50, they are also equal. So this condition, and tau xy is 0, means there is no shear stress acting on this element. So if we draw more circle, we do not have any shear stress, so shear stress will be 0, and sigma x sigma y, if both are similar, there will be one point on this horizontal axis sigma axis. So more circle will be point, and this is called as hydrostatic stress state. And if both these value are negative, then we'll get on this side of this vertical line. Here I am assuming both are positive, so on this right side. But if both the sigma x and sigma y both are equal and negative, then we'll get on left side any one point. So this is a special case. The other special case is when we do not have normal stresses sigma x sigma y equal to 0, but we have tau xy. So this that is the case of pure shear. And in pure shear, if we plot on Mohr circle, we have to plot one circle from 0 0 line, because sigma x sigma y are 0 0, and we have tau xy, so both these will cut at these two values. Sigma x is 0 here, if we take 0 comma tau xy, here 0 comma minus tau xy. So if we plot these 2 points and we draw a line diameter and we draw a circle, we get sigma 1 sigma 2, that are also the radius of the circle. So here sigma 1 magnitude sigma 2 magnitude will be equal to tau xy only, and tau max is also tau xy, and sigma 2 is compressive, so it will be in negative direction. So that is the case of pure shear. So these two are special cases, and they are asked very often in the examination for 1 mark. And this is a very easy concept, and very intuitive as per the figure. So see you guys in the next video, and thank you for watching this video.